Hello again. So here is our second lesson on projectiles, which is going to take what we did yesterday and it's going to expand upon it and have allow you some time to consolidate everything that you've done. So we have a particle projected from a point O on level horizontal ground, a speed of 23.8 meters per second at an angle theta to the horizontal where tan theta equals 15/8. The particle is moving freely under gravity, reaching a greatest height h, and then it lands on the ground at point A. So this is following the same theme as all of the questions that you have attempted so far. We have an angle, we have gravity, we have a greatest height, and we have a landing point. So let's have a look at first at this theta, because we know that when we're going to resolve our speed, 23.8, we're going to use sine theta and cosine theta. So we're going to have a look in detail at this. Tan theta is 15/8, which means that if we have a right angled triangle here, there's our theta. That means the opposite side is 15 and the adjacent side is 8. Opposite over adjacent. And using Pythagoras theorem means that we have this hypotenuse, which is 17, giving us sine theta is 15/17. Cosine theta is 8/17. So that's important to get out of the way. Second thing we're going to do is we're going to draw this diagram. So we have our 23.8 meters per second, our speed. We have our angle that the speed makes, which is theta. Just show that angle is right there. We have the point O of projection and the A, which is the landing point. So we're going to use all of the facts that we used yesterday. Part A, we're going to determine the distance of OA. Now, the distance OA is also known as the range of the particle. Okay, so the range of OA, we're going to resolve horizontally. And again, remember, horizontally, there's no acceleration, so we're just using speed, distance, and time. So distance equals speed multiplied by time. So the horizontal distance is given by the horizontal speed, which is 23.8 multiplied by cosine the angle multiplied by the time that the particle is in the air. Now, this is a problem at this point because we don't know the value of t. How can we calculate the value of t? Well, the only other thing we can do with projectiles is resolve vertically. Now, don't forget to use your capital R to show that you're resolving and which direction you're resolving. So whenever we resolve vertically, we're going to use suvat because we have our constant acceleration due to gravity. So if we consider the displacement vertically between O and A, we have a displacement of 0. It's gone into the air, it's come back down. Okay? And it's horizontal ground, meaning the overall displacement is 0 in this case. The initial velocity there is 23.8 multiplied by sine of the angle, because this is the vertical velocity and it's opposite the angle that we're working with. Our v value is not anything that we're interested in. The a value is minus 9.8 because it's moving freely under gravity, and t is what we're trying to work out. So which of our equations do we use? S equals ut plus half at squared. So substitute in the values that we know. 0 equals u times t. Now, at this point, I'm just going to work out 23.8 sine theta, which is 23.8 multiplied by my sine theta, which was 15/17. And that's nice because it comes out as a whole number. So we've got 21t minus 4.9t squared. So again, just to summarize, this 21 is what you get when you do 23.8 multiplied by sine theta, where sine theta is 15/17. So we'll factorize t, 21 minus 4.9t. So our two values of t equals 0, that's the beginning of the model. And then we have t equals 21/4.9, which is 4.3 seconds. I'm going to keep that in my calculator unrounded, and I'm going to take this value of t now and substitute into here. So we've got s equals, now 23.8 multiplied by cosine of the angle is 11.2. So we've got 11.2 multiplied by t. So s is going to be 48 meters. And so there we have the range from O to A, the horizontal distance covered by the particle, given by the two calculations together. For part B, H is what we're after. This is the greatest height of the particle above the ground. And again, this is a pretty standard problem. If we want to find the greatest height above the ground, let's resolve vertically. Again, we use our Suvat equations. And we'll put in what we know. S is what we're trying to work out. U is 23.8 multiplied by sine theta, which we've already established over here, is 21. V is 0. Whenever we reach the greatest height, it has an instantaneous velocity of 0 meters per second as it stops before it drops back down to Earth. And the acceleration there is minus 9.8. So the equation we need to use is v squared equals u squared plus 2as. So 0, which is our 0 squared, equals u squared, so 21 squared, 2 times a, which is minus 19.6, s. And so we can work out our value of s by doing 21 squared over 19.6. And we get 22.5 meters above ground. So our part C says calculate to 3 significant figures the speed of the particle when it's at a 20-meter height above the ground. So this is where we need to think about speed rather than velocity, but in order to calculate speed, we need to know the velocity. So resolving horizontally, remember the speed of this particle is constant. Okay, so we're just going to use the fact that our u value is 23.8 multiplied by cosine of theta, which, as we used in the last part of the last question, comes out as 11.2. Then we need to know the vertical component of this velocity, and to do that, again, we're going to use Suvat. So this time our s is 20 meters because the particle is 20 meters above ground. Our u is 23.8 multiplied by sine theta, which as we saw before was 21. Our v is what we're trying to work out, and our a is minus 9.8. So we're going to use the same equation as for part B, v squared equals u squared plus 2as. So v squared is what we're trying to work out, is 21 squared plus 2a, so plus 2 times minus 9.8 is minus 19.6, and the displacement is 20 meters because that's how far above the ground it is. So v squared comes out as 21 squared minus 19.6 is 20, is 49, which means our velocity is 7. So how do we put these two together to work out what the speed is? Well, we can see what we've got here is a particle that's traveling in this direction at this point. Its horizontal velocity is given by 11.2. Its vertical velocity is given by 7. So to work out its speed, we just need the hypotenuse. So the speed of this particle is given by the square root of 11.2 squared plus 7 squared. And let's just work that out. We got 13.2. What was our accuracy? 3 significant figures. So we have 13.2 meters per second. So there we have all the classic parts of projectiles. We have lots of resolving vertically, mainly resolving vertically. Then we have our horizontal resolving as well, where we just have to remember there's no acceleration and we're using a constant speed. And then if we're asked for a speed at a certain time or at a certain point in time, then we can use Pythagoras' theorem by working out horizontal and vertical velocities. So there we have it. Okay, have a go at the questions that are in the lesson plans area, and I look forward to working with you.